We are given a polynomial function and are asked to identify the zeros. Right, so first we have to set the function as equal to 0. Second, we have to simplify the function and solve for x. There are multiple methods, but we will be using the method of factorizing. Now, the least common multiple between these two values is 3x squared. Multiplied by x, take away 2. Because 3x squared multiplied by x equals 3x cubed. And 3x squared multiplied by negative 2 yields negative 6x squared. And everything else is written as it is. Now let's factorize these two values. The least common multiple between these two is negative 4. So we take negative 4 out, multiplied by x, take away 2. Negative 4 multiplied by x yields negative 4x. And negative 4 multiplied by negative 2 yields positive 8. Notice that these two brackets are the same. It is only when we see that we proceed with the factorization. Now let's combine these two values between brackets. 3x squared take away 4, multiplied by x take away 2, multiplied by x take away 2. Now we have two of the same brackets. We can write them like this. X take away 2 squared equals 0. Now we can go ahead and solve for the values of x. Let's start with these values over here. 3x squared take away 4 equals 0. Adding 4 to both sides of the equation and dividing both sides of the equation by 3. Now we take the square root of both sides of the equation. Now the square root of something to the power of 2 cancel each other out. Now positive the square root of 4 over 3 is 2 multiplied by the square root of 3 over 3, which is 1.15. And negative the square root of 4 over 3 is negative 2 multiplied by the square root of 3 over 3 equals negative 1.15. We have found two values of x. Let's deal with the last brackets. Now x take away 2 squared equals 0 is basically x take away 2 equals 0 and x take away 2 equals 0. X equals 2, x equals 2. We have found the values of x. Let's put them to the side. Now, let's find the maximum number of turning points. To find the maximum number of turning points, we take the highest degree n of the function and we subtract it by 1. The highest degree is 3. So 3 take away 1 is 2. 2 is the maximum number of turning points. Let's find the y-intercept. The y-intercept is when x equals 0. So we take f of 0 equals 3 multiplied by x, which is 0 to the power of 3. Take away 6 multiplied by x, which is 0 to the power of 2. Take away 4 multiplied by x, which is 0, plus 8. So our y-intercept is the point 0, 8. And finally, we have to write the intervals of when f of x is below the x-axis. So we're going to have to draw our function. So we have the 0, negative 1.15 and positive 1.15 and 2. Our function will look like this. So our intervals will be of when f of x is below the x-axis, so this region over here. Right, so coming from negative infinity until it reaches negative 1.15, it is below the x-axis. So x equals negative infinity, negative 1.15, and coming from positive 1.15 until 2, it is below the x-axis. So positive 1.15 and 2.